All right. So we're excited this morning. Stand behind the podium or stand in front of the mic. Yeah, okay. We're excited this morning to be announcing a new version of the OpenType specification, OpenType 1.8. And so this morning we're going to be telling you about what's new. As I tried to think sort of at a high level, is there a theme that I can bring out to reflect what's 1.8 all about? And what first came to my mind was this quotation from an ancient Hebrew poet. There's nothing new under the sun. As I talk about some of the things, you may get the feeling that there's really nothing new here. So the first thing, I think it was a few months ago that Adam Torok noticed that in the Windows 10 anniversary update that we're supporting all of the different color formats now. And that's true, and in fact, all means actually all. So in Windows 10, we're supporting SPICs, and we're going to reflect in the OpenType spec the reality that there are 4 different color formats. So is this new? Well, SPICs table's been around for a few years now. We're adding a metadata table, and the metadata table can be used for all kinds of metadata. Right now, we're using it for language information. If you've noticed that the OS2 Unicode range table has been obsolete for a few years. We used the last bits after Unicode 5.2 was published, and we're up to Unicode 9.0 now. And so it's been kind of overdue for some other mechanism, and the metadata is one way that we can use to indicate language information. This also isn't quite so new, because in Windows we've been supporting this since the first release of Windows 10, and Apple has been using it for your free users as well. We've added a merge table. The merge table can be used to provide good balance between good quality rendering and performance. When you're doing anti-alias filtering, some implementations like to cache the results in order to improve performance. And so you take the cache result of a rendered glyph after anti-alias filtering and then compose those together. But if the glyphs are overlapping, then composing after the filtering can produce artifacts. And so you want to know cases where you should be merging the glyphs together before you do the filtering. And so the merge table is a way of indicating in the font those things that should be merged before filtering. This also isn't new. We've been supporting this in Windows since Windows 8.1. We just somehow forgot to add it into the OpenType spec. If you've been following the corresponding ISO open font format standard, you'll know that there's been some revisions to the last edition of the ISO standard, and OpenType 1.0 will incorporate those different changes. And so, okay, that's been out there for a little bit. Not so new. So, there's nothing new under the sun. Well, now I'm going to talk about something completely different, but well, if there's nothing new, then maybe it's not so completely different. I started thinking about Ecclesiastes, and were there any other things that he had to say that kind of reflected what we're doing in OpenType 1.8? And there was these other passages. What's been done will be done again. For everything there is a season. I think this is an apt description for what we're introducing now in OpenType 1.8, which is OpenType Font Variations. Now, if you've been at the sessions earlier this morning, you've heard the word variations and interpolation referred to several times. And so, maybe this isn't something so new. What is OpenType Font Variations? First of all, it's variable. You've got the ability for a single font to behave like multiple fonts. And so at runtime, a font can vary on some design axis, such as this example of varying weight on a continuous range of weight variation. Or possibly multiple axes, in this case, weight and width. Or possibly 3 or even more axes. There's no practical limit to the number of axes that you can support in a single font, though in terms of what's usable, there may be practical limits. So we have this notion of multi-axis fonts, where each axis is an independent and font-wide variation. Now, when I say font-wide, that means that the setting on an axis is applicable to the entire font, though not necessarily every glyph changes for every axis. You may have all glyphs in the font adjusted by an axis or only some glyphs. We've got a set of known, or what we refer to as registered axes that are defined in the OpenType spec. 5 different axes at this point: weight, width, optical size, slant, and italic. Fonts can also support custom axes that you get to define. Now, over time, if there is a set of axes that we find are popular, commonly used, those can be added into the spec as registered axes. Because we're now putting the ability for a single font to vary on many different axes, we force a paradigm change in terms of the notion of family. As type designers, you've for a long time probably thought of a family in a large sense, potentially having many different kinds of variations. And yet software implementations have typically imposed certain more limited notions of a family. For instance, in Windows and the Direct Write platform, the existing notion of family has been one that allows for weight, width, and slope variations. By introducing variable fonts with many different axes, we are going to be forced to change our platform implementation to allow the notion of a family to have any number of axes. OpenType Font Variations is integrated fully into the OpenType spec. We've got variation data for all of the relevant OpenType tables. So OpenType supports different outline formats, and we support variations for both of those, for both TrueType and CFF outlines. Variations for font wide or glyph metrics. Variations for the OpenType layout tables. The only existing limitation for now is that we don't have support for variation of SVG or math tables. Font variations are going to be interoperable. The fact that we've got 4 major companies here should be a statement that we are expecting this to be supported in all major platforms, OS platforms, and major content creation platforms. We've defined in the spec not just the formats for representing data, but also the algorithms that are needed for how the data gets interpreted, so that we are trying to be sure that when you create variable fonts following the OpenType 1.8 spec, that they will work everywhere. Because we've got this set of known axes, the semantics of those axes are well defined and interoperable. And this is something that is significantly different from the old TrueType GX format, because in GX, you could define a variation, but that variation had a numeric range that was proprietary to that particular font. There was no way to compare two different fonts. And an implication of that was, if you had, for example, some CSS styling, so this is some existing CSS, font weight, font stretch, there's no way to compare a font weight of 900 with the value in a GX font. By defining the semantics of the axes in the OpenType spec, we allow for this kind of interoperability between fonts and different platforms. Font variations are efficient. Inside the font data, we represent a single set of glyph outlines plus a set of deltas. Deltas for the outlines, deltas for other values in the font. And that gives you a smaller, more efficient representation of the data. You get significant disk footprint benefits, and then also in web font scenarios, better performance in terms of font download and bandwidth considerations. We also think that the variable fonts can allow for more streamlined font production. For example, if you are creating a family of CJK fonts with, say, 3 or 4 different weights, and you want to hint some number of glyphs from those fonts, you've got to repeat the work for 3 or 4 different weights that you're doing. In the case of a variable font, you only have one set of outlines for the whole family. You only have to do that hinting once. I'll talk a bit more about that a little later. So overall, we think there's this notion that variable fonts provide more with less. Font variations, we think, are familiar, or should be familiar with most people now. With existing tools, like we saw this morning, the tools have been designed to design a family of fonts with the notion of variations, where you start with different source masters and interpolate the instance production fonts that you're going to generate. Except now, those same concepts are going to be applying, doing the interpolation on the platform at runtime. We wanted to make sure that the formats that we created were going to be amenable to the existing workflows and tooling out there to be easily adapted to it. And finally, we think that font variations is promising. As we implement support in our platforms, that's really going to represent just a starting point, because the capability of variable fonts is going to enable a number of new application opportunities. For example, we talk about responsive design. Well, the variable fonts, for instance, could allow automatic adjustment of widths as you have different column widths or as you adjust to different form factors. Or perhaps having a graded adjustment of the designs to accommodate different print media or display properties. So I want to do a quick demo now. I have to do a quick transition shift. And why is that not? Oh, because I need to do that. Okay. What I'm showing you here is some pages viewed in the Windows Edge browser or Chrome. This is running on the Windows 10 anniversary update. And what you're seeing here is a single font that is presented in many different variations. Right, one font at runtime presenting in many variations. So we've already got some very limited functionality built into the Windows 10 anniversary update. The TrueType rasterizer has been modified to support variations at runtime. It's only TrueType that we've got implemented at this point. And so this isn't ready for prime time, but it's enough for you as font developers to begin doing some prototype development and being able to see some results on shipping software. We're going to be working towards completing our implementation in Windows for releases in 2017. I want to show you also quickly, give you a little sense of the kind of file savings that can be obtained. So in this demo, we created a prototype of the SigoUI font that supports, we created it as a variable font and then produced static instances from it and then used that to do a file size comparison. Now this is a subsetted version of the SigoUI font. It doesn't have hinting and it doesn't have any OpenType layout tables. I'll comment again on that in a moment. So we're seeing here 5 different weights coming from 5 separate static fonts. And the combined file size of those different fonts is 657 kilobytes. Now we repackaged that as a TTC file. And of course in a TTC file you can dedupe the tables that are identical. And so we get a small file size saving from 657 down to 525, so 132 kilobytes in reduction. Now I'll show you what you get if this is engineered as a variable font. From 657, you go down to 199 kilobytes. So that's almost 70% savings in file size. Now I mentioned this is just a subsetted version of SigoUI and it doesn't have hinting data and it doesn't have OpenType layout data. If all of that was there, the savings would be even greater. We also did a 2-axis version of this with weight and width. And so in this case, we produced 10 different instance fonts and a little over 1 megabyte. And the TTC gives you a very modest savings, but again, about 70% savings when we go to the variable font. The font variations work has been an industry collaboration. I want to give you a little historical perspective on how we got to today. If we go back a few years, there's been some significant developments in the type industry. So first I'll mention the development of CSS3 web fonts, which of course brought a lot more typographic variety to the web, use of a lot more fonts. And then, of course, we've seen the explosion of mobile devices, and that gave rise to interest in responsive design. But this combination of things has led to a couple of challenges. One, if we talk about responsive design, well, it's great to be able to adjust column widths, for example, but how do you make the typography responsive, right? There haven't been a lot of good mechanisms for doing that. And then, for both mobile and web, we've got these file size issues and bandwidth issues. Those have been challenges up till now. And that's led some people to ask, well, what about Apple's GX technology? Could that help with some of this? So we at Microsoft, and we knew that some of our partners, had seen these motivating factors, the file size efficiency issues, the potential for reduced font development costs, primarily in terms of reduced time for development. There's also the motivation of the greater flexibility that's provided to content creators from variable fonts. And there were also some independent issues that we had that didn't specifically have to do with variations, particularly around this notion of font families. I'll talk a little bit more about that in a few minutes. So late last year, we at Microsoft looked at what was happening, looked at the level of interest across the platform vendors, and we thought, you know, we can make this happen. Now can be the season for variable fonts to really succeed. So at the beginning of January of this year, I reached out to Apple to talk with them about working together along with others to integrate the Apple's GX variation technology into OpenType. At the beginning of February, Behdad distributed a document in which he was doing an exploration of what it would involve to combine GX variations with OpenType. Now, at that point, he didn't know that I had already reached out to Apple, because it took a few weeks for me to talk with my lawyers and Ned to talk with his lawyers and figure out yada yada. But shortly after Behdad distributed his document, I was finally able to reach out to folks at Adobe and Google and say, hey, we want the four of us to work together to do this work. So then in March, the middle of March, in fact, exactly 6 months ago today. So sorry, this has actually been 6 months in the making. We had our first face-to-face meeting, and at that meeting, it was representatives from our four companies. We identified all of the different technical challenges that we were going to have to solve. We had a set of concrete proposals for many of them already at that point. We reached consensus on a set of goals for an initial release and a timeline, and that timeline included being here this week at ATypI to announce this. From April through July, we had some more meetings where we continued to work through building consensus, not only on the formats, but also on the algorithms that we need to use. And so at the end of July, we had completed beta for the 1.8 specs. And then in August, we invited a little broader ring of reviewers to give us feedback on the specs. And that brought us to today. So the way that this has worked, I think we can say that OpenType font variations can be considered an industry standard. We've had this collaborative process across all the major platform vendors. We've worked on designs to accommodate the different requirements that we have in different implementations to make sure that this will work well everywhere. We've been inclusive from the outset. The GX variation format was designed for TrueType. We wanted to make sure from the outset that this also supported CFF. And we had this goal to ensure interoperability, as I've already mentioned, defining the algorithms as well as the specification of the formats. We've also decided to collaborate on some test suites so that we can validate that on different platforms, we are all producing the same behavior. Now, along the way, someone gave me this quotation. The type designers have a long collective memory. They remember the original hype with which Apple announced GX and Adobe announced multiple masters. And they're deeply distrustful of claims about revolutionary technologies. So if you've been hearing this and you have some questions, there's a valid question. If Apple's GX variations and Adobe's multiple master didn't succeed in the 90s, what makes you think it's going to succeed now? Well, this is my own perspective on some of the reasons why variation technology did not succeed in the 1990s. First of all, digital type was still young in that era. If you think about it, we had this explosion of computers going onto desktops in businesses, and people that just a few years earlier had been creating documents on typewriters were now using word processors and desktop publishing software. They had the typographic sophistication of a typewriter, and they had to be retrained. There was a lack of font development tools. That was a big blocking issue. And we had these competing formats. This was the era of the font wars. And so it was hard for anybody that wasn't one of those main vendors to commit to a particular format because it wasn't clear what was really going to succeed. And there were, to some extent, there were different priorities that people were juggling. Not everybody had this as their top priority. We've got a very different climate today. First, we've got a much more mature content creation industry with a lot more typographic sophistication. We've got common font tools, as we've seen this morning, that are already using variation concepts for font development. We've got a commitment from all the major platform vendors to be supporting the same format. And we think there's a widespread interest. So we really think that there is a different climate now than existed before that will be enough to make this succeed today. So I think it's fair, taking one more quotation, to say that reports of the death of font variations have been a little exaggerated. So what's the current status? As of this morning, Aaron's at the back pushing the buttons even as I speak. The OpenType spec is being published, 1.8. We've got, as I mentioned, we've got the conformance suite that we're working on, so development of that is in progress. We've got platform implementations that are in progress. Work has been started, but we're all working. And you can expect to see product releases beginning next year that will be supporting variations. I mentioned in Windows, we've got a little preview of functionality in the Windows 10 anniversary update. We're committed to Windows releases, updates in 2017. We're also working on adding support in the VTT hinting tool for supporting variations. Other tool vendors are committed to supporting this or are already doing work in progress. And I think, in fact, if the order of presentations this morning had been different, you might have heard a little more from the Glyphs and Font Lab folks. And then the web, of course, is a major platform. And that is our next step, is we want to be engaging. And our four companies are all committed to working together to submit formal proposals. That process will actually begin next week at the next TPAC meeting. So I'm going to hand it over now to my partner, Ned, who's going to go a little deeper in some of the basic concepts of variations.
Not too deep into the technical details, but I just want to talk a bit about how the technology is implemented in OpenType. The starting point is really to talk about axes. This is essentially the interface that the font presents to the world. It's, in technical terms, it's defined in the FVAR table in the font. And what axes do, as Peter mentioned earlier, is they define a variation space of at least one, but possibly more dimensions, a rectilinear variation space. These axes can be both registered, as mentioned, or they can be custom. Custom axes are given the ability to associate a name with those, with each axis, so that it can be presented to a user. And internally, these axes all have identifiers for use in the internal processing. So, as Peter mentioned, the registered axes have known scales, that's so they can interoperate and have some semblance of conformity with other specs. So An example would be the weight scale, which we've matched up with the CSS and OS2 weight class. So that is an axis that has a possible range between 1 and 1,000. But of course, since variable fonts are truly variable and interpolated, you're not limited to simply 1,000 different weights. It is completely continuous. But designs don't need to cover the whole range. By defining the semantics of each of those axis ranges, you can have a font that only supports, say, weights of between 300 and 800. Each axis defines minimum, default, and maximum values. A default is just the value that corresponds to that particular axis having no effect on the outline. And the mapping from the axis ranges to the internal variation processing space is usually a linear mapping, but it can be piecewise linear. So now that we have these variable fonts, how do you actually use them? Well, any particular configuration of those axis values is called an instance. So an example would be a font with weight and width axis. When that variable font is used with a particular configuration of weight 350 and width 125, that is a particular instance of that variable font. Fonts can define named instances using the FR table. This is equivalent to having a font family that presents, a regular, bold, semi-bold, whatever. And so those named instances are what are presented to the user in a font picker dialog. We don't expect to see a lot of sliders. I think there'll be a lot of investigation into what appropriate UIs for this will be. The default of all the axes is referred to as the default instance. This is called out because when all of the axes are at their default value, that means that no modification is made to the outline. So that corresponds to that single set of outlines mentioned by Peter that is in the font. And that also corresponds, for historical purposes, to all of the unmodified metrics in the font. So like the OS2, the head table, all these things have font-wide and glyph-specific values, and that corresponds to the default instance. But when we're talking about instances, so I've said that there can be named instances that are particular configurations, but I think the most important thing to stress is that named instances or instances of any sort don't need to correspond to design masters. So you might be used to designing a font with masters at the extremes of axes, and that's fine, but that is not a requirement of the implementation. So how does that work? Well, TrueType outlines for glyph variation data use the GVAR table. Cubic outlines use the new CFF2 table, which David will be talking about shortly. And basically, the glyph variation data describes how to move points on the outline. And so for any given point, there can be an adjustment, which we call a delta. And really, the process of interpolation uses the values of the axes to apply these individual deltas to a certain amount. And so the way that works involves a few minor technical details, which I'm going to skip over here. And I'm going to go straight to the actual purpose of interpolation here. So the deltas themselves can correspond to any position in the design space. And so, like I said, when you're designing your font, you can choose exactly where your masters are placed in that design space in order to guide the process of interpolation. But really, we expect that the tools that you are using will be the ones that are responsible for translating your design intent into the encoded font variation data. And so we really want to stress that this accommodates many different design techniques. And so really what we have here is a process which hopefully will take the variable font development techniques that you've engineered and make them available directly to your clients and users. And with that, I'm going to pass it over to Behdad, who will give you some slightly different technical details. Thank you.
Thanks, Ned. So I'm going to present for you, for those of you who enjoy reading the spec, guide you through the additions to the spec. So again, font variation, there's this interpolation algorithm, and you can apply it to anything. It's, most of the time it points with X and Y, but you can apply the same technique to any font-wide number. Like it might be the font ascent, descent, it might be any number can now be interpolated, and I'll guide you through where those are stored, and then some other features of the OpenType layout. So at the very beginning is the font-wide variation metadata, and that's stored in the fvar and avar table. The fvar, as was mentioned twice already, supports arbitrary access, and then you have named instances. Again, you might have only 3 masters, but you can define 9 different instances, and they show up in a font dialog. And the names of these named instances refer to the name table, so they can be translated. And then we also, fvar also streamlined the standard access. And the avar table, which was briefly mentioned, is how you go from a linear interpolation model to a piecewise linear, but that can be arbitrarily more accurate. So that's if you want to use Luke's interpolation curve or Pablo's, whichever you prefer. I can't make up my mind. That's where you put this curve. So that while we say this is linear interpolation, you can actually go to non-linear interpolation as needed. On the glyph shape variation is where the bulk of the variation data is. That's where you get the glyphs from all the masters and then encode them as these deltas. And for the, again, these technologies supports arbitrary master configuration. They don't have to line up with your axis master. You can just have arbitrary masters, and that's on a per glyph basis. So again, if you are, as we saw, the Glyphs app has this brace trick. Those kind of things are supported by the system. And then for the TrueType outlines, glyph table, the variations are stored in a new table called gvar. Well, that's carried from the TrueType GX. We know that, of course, because it's lowercase letters. And then for CFF, Adobe took a different approach. They wanted to do some house cleaning, so the glyph outline and the variations are all stored in a new CFF2 table. And there's the font metrics that can be your ascent descent or OS2 features, typographic ascent descent, post table, all those things that now need variation. The variations for those are stored in a new table called the mvar table, which is extensible for future font-wide metrics as well. It's working. So one of the main differences between OpenType GX and OpenType font variations and TrueType GX is support for OpenType layout variations. In this case, what we are seeing here is subpositioning variations. So you have your masters in your design, and they have different axis and attachment positions. That also translates into variations for the GPOS, mark and kern and those features. And the variations are stored in GDEF table that I referred to from GPOS. That's consistent with how GSUB, GPOS, GDEF work together. And then we also have conditional features in both GSUB and GPOS, whereas for parts of the design space, you can substitute a different lookups to be applied for an OpenType feature. In this case, we are saying, for example, switching to a different design if weight is larger than a certain amount. Now, I guess Glyphs calls that the bracket feature trick, and Superpolator has its own conditional substitution. Again, you just keep doing that, and the tools translate that to this setting. There's glyph metrics variation. You don't need to care about that. They are just for optimization technique for layout. but the advanced with left side pairing, right side pairing, they go into the new H-bar table, and the vertical metrics go to VVAR. And for CFF2, because the advances are not stored in CFF2 table, the H-bar table is mandatory, but VVAR is optional. And the hinting data, again, TrueType hinting is more bytecode oriented. There's support for accessing variations from hinting bytecode, and the CVT values can have variations stored in the CVAR table. CFF flavored OpenType fonts include variations to hinting as part of the char string, and Peter will talk about the TrueType hinting now.
David will talk more about CFF2. I will talk about hinting, specifically TrueType hinting for variable fonts. When you're hinting, you're creating relationships that involve X or Y distances, and these can be relationships between two or a set of points, outline points. For example, if you're looking at a capital B and deciding on the midpoint vertically, you may be defining that midpoint as an interpolation, a proportional interpolation between the top and the bottom of the B. So that's a relationship between those outline points. Or a relationship between outline points and some key metric values of the font. For example, setting the points along the top of a lowercase x to the x height of the font. Now, if you think about those kinds of relationships, exactly the same relationships will be applicable for every different instance of the font across the family. And the specific XY distances may be the things that possibly change, but the relationships can be the same. And that's exactly the approach that you want to be taking as you think about hinting, TrueType hinting for a variable font. So the process that you would go through is, after you've completed drawing the outlines, define the hints for those default outlines and set up the key CVT values that you need. And then review the non-default masters that are significant. Now, this is a point where you may need, depending on your tooling workflow, you may need to be aware of how your original source masters got translated into variation data with the font, within the font, because you want to be focusing on those particular points where the deltas are defined in the font. Focus on those and to figure out what corresponding CVT adjustments are needed for those particular points. And then the tools should take those adjustments to the CVTs and from that generate the CVAR table data that you need. When you've done that, then you can proof the non-master interpolated instances to make sure that you're getting the visual results that you expect. Some hinting recommendations: if you're using VTT, we recommend that you use the res commands. The res commands are sensitive to different rendering modes, such as whether there's vertical grayscale or color clear type hinting going on, for instance. And we recommend those in particular for variable fonts because we feel like those results are actually going to give the best overall results across an entire variation space. Don't use a lot of CVTs. The more CVTs that are defined, the more things you may need to define adjustments for. So if you can get away without defining CVTs, that'll save you some work. And avoid delta hints. A delta hint is specifying a very specific X or Y adjustment that's going to apply across the entire variation space. That probably does not make sense. So don't use delta hints. If you're someone that does advanced hinting, working directly with the TrueType instructions, as Behdad mentioned, there's a couple of instructions here. The getInfo instruction that already exists has been updated to be able to report support in the interpreter that you're actually running with on whether it supports variations. And then there's a new get variation instruction that will report the axis values of the current instance so that you're able to do some conditional instructions. Okay, I'm going to give you a little demo here, another context switch. Yeah. So giving a little demo in VTT. As I mentioned earlier, the team that maintains that is working on adding support for variations in it. The UI that I'll show you today isn't necessarily the final UI, but it'll give you a sense of the direction in terms of workflow that you'll use in VTT. So these windows should be familiar. The main window where you define the hints on your outline, and then the control program window that you use to set up the CVT values. So this is where you work with the default outlines as you would work with a static instance font today. Then you can pull up a waterfall and review the results that you get in the waterfall, just as you're familiar with. The next step now is then you want to look at how things look in some other master instance. Now for this, you're going to want to have set up named instances in the font that you care about. And so we'll pull up this other window. This is a window where you'll see or be able to edit CVT values for other instances. And in here, I can select the different instances. So I'm going to pick bold because that was one of the master designs used in this font. And watch the waterfall as I change this. So the waterfall is reflecting the particular named instance that has been selected. The main window does not change. The main window always shows the default outline data. So I've picked this other instance that I'm working with, and now I'm going to pull up this other window that looks like the main window, but it's different in that it's reflecting the named instance, not the original outline data. I can't edit the hints in this window. I can only edit the hints in the main window. But what I can do in this other window is I can use the measure tool to go and determine what are the CVT values that I want for that particular instance, and then come back here and edit the CVTs for this particular value. When you edit those, then VTT will be generating a new CVAR table as needed. So before I get off this, I realized a couple of important points that I forgot to mention. And we need to switch. Oh, no, that's right. Oh, I lost my place. Okay, hang on. Context switching in a presentation is always easier with a KVM switch. Okay. Yeah, so before I get off this, some things to keep in mind with variable fonts is that, as we've been mentioning, there's just one set of outline data. So if you were creating an entire family of fonts and you wanted to hint all of those, all of the different design variations as a set of separate static instance fonts, then you've got multiple sets of outline data to hint. In the variable font, there's just one set of outline data. There's one set of CVTs that are created. And so you only have to hint once to cover the entire family. And that can provide a very significant savings in time of development. You can ask Rob, who did a project recently doing some hinting, and he can tell you that he hinted an entire family of how many? Yeah. Manual hinting with a font that was targeted at 6 particular instances and did all the manual hinting in an hour. Okay. So now I'm going to hand it over to Dave to talk about CFF2.
Good morning. I wanted to say a few words to start with about what CFF is and why we're changing it. So 20 years ago, Adobe created the compact font format as an improvement to the original Type 1 font format. As you can guess by the name, CFF was designed to be a lot more compact. It was as compact as we could figure out how to make it at the time. But it was just an evolution of Type 1, so it had the same primary features. It still used cubic curves. It had a lot of information in the individual car strings, the glyph names, the advanced widths, the hints, and all that. And those hints, of course, were the same simple declarative hints that Type 1 had introduced. A key piece about CFF is that it was designed as a self-contained font format. So it was originally used in PostScript printer memory to store fonts there. And it was also soon after that used when we introduced Acrobat with PDF files with embedded fonts. So the fonts embedded in PDF are stored in CFF form. And for these purposes, the whole thing had to work together as a fully functional font. Later, when we worked with Microsoft to create OpenType, and we wanted to continue to carry PostScript style outlines forward, we introduced the CFF table as a sort of a supplement to the OpenType font format. It was referenced by the format, but not really included in there, and serving as kind of an alternative to the OpenType's glyph table for TrueType outlines. So 20 years later, a lot has changed. We have decided to break with the past and create a CFF2 table as part of OpenType 1.8. The CFF that you're familiar with will continue to work just fine. You can keep building fonts as you always have. But if you want to take advantage of some of the new stuff, we'll be using CFF2 for that. It is now just a part of the OpenType font format. It no longer a self-contained font file. And so this enabled us to remove a lot of information from the car strings and other parts that had become effectively redundant, and reference those from the other OpenType tables that cover that stuff. This makes CFF2 outlines behave a lot more like a full citizen of OpenType, and reduces the differences between TrueType and CFF. And it also lets us make things still more compact. We've made a variety of improvements. As Peter mentioned, we reintroduced the blend operator that we had used with some modifications from its multiple master days. We changed the car string format to make it even more compact with the benefits of 20 years of hindsight. We introduced another benefit. Some of you are familiar with our CID font format that we've generally used for our East Asian fonts. One of the benefits of CID was that it allowed you to hint different sets of glyphs with different sets of hints. Whereas normal Type 1 and CFF2 name-keyed fonts have one font-wide set of hints. There are now multiple hint dictionaries in CFF2, as there were in CID, and we're effectively deprecating CID and removing the distinction between CID and name-keyed fonts. My team and another team at Adobe, both part of Typekit, have been working very hard on implementing all this stuff. We've completely rewritten the CFF2 specification and the char string specification. And those are now live as part of the new version of the OpenType spec. We're also, specifications are just a small part of what needs to be done. So we're contributing, you maybe remember a couple years ago, we donated some of our CFF rasterization code to FreeType. Werner's here, who worked with us on that. Now we're updating that code. You'll see some of that stuff running in demos today. Besides adding support for variations, you'll have noticed in the talks from the Glyphs and Font Lab folks that people designing for interpolation today are habitually using overlapping paths and self-intersecting paths. It just makes interpolation work a heck of a lot better. All this stuff has been removed by the tools when people write out individual instances to ship as standalone fonts. And that is in part because certain rasterizers at particular sizes were not set up to handle overlapping paths or self-intersecting paths. But in order for the interpolation to keep working well, the rasterizers have to change. So we're changing the CFF rasterization to handle this stuff. We're obviously, yeah, that's so we're creating new tools to do this stuff painlessly, as I will demonstrate shortly. We'll ship a new version of the AFDKO with a tool for building variable fonts. We expect to have that out by the end of the month, along with at least one sample font. We're creating test fonts for the rasterizer development, which is ongoing for a while yet. And for the longer term future, we're planning a fairly large number of variable fonts that we plan to release. Most importantly, perhaps, we're working with the Adobe product teams to get variable font support into the applications, because I think this is where it's going to really get interesting. So with that, I'm going to hand it back to Peter.
So I want to tell you about another table that we've added, the style attributes table, or stat table. This is something that isn't specific to variable fonts. It's required in variable fonts. We also recommend it for any new non-variable fonts. The particular problem that we're trying to solve was this issue of different notions of a family. How do you deal with families that have got designs for many different axes and many different instances on those axes when you're working with existing software that has more limited notions of a family? How do you bridge that gap? By supporting variations, this is one of those other independent problems that we were forced to solve. So consider the Sitka optical size variants. The Sitka family was added to Windows in, I think, Windows 8.1 and supports optical size variants. But this is a non-variable font, static instances, and for different optical sizes. And in Windows, with Direct Write having a weight, width, slope family model, the different Sitka instances are presented as discrete families. So you have Sitka caption, Sitka text, Sitka heading. And so I think 2 years ago, after 8.1 shipped, then the advanced reading team that developed the Sitka font came to the graphics team and said, you know, it would be great if we could get the platform automatically selecting the appropriate optical size for the given text size. And we said, well, that sounds really interesting, except we have a problem, because if we were to make that happen automatically, then we no longer have Sitka display, Sitka caption. We just have plain old Sitka. Our APIs aren't set up that way. So we can change that, but how do we actually make that happen? So you're familiar with the fact that inside the font, you've already got these different name table pairs. So name ID 16 and 17 for the most generic notion of a family, but you've got 1 and 2 that you have to set up to support software that supports this older so-called GDI model of a family. And then we've got name IDs 21 and 22 for applications that support the weight, width, slope model of a family. And I'm sure you really love this proliferation of name ID pairs. So if we were going to add optical size into a platform model of a family, are we going to create another name ID pair? We said, I don't want to do that. If we're going to do this, we have to come up with a more generalized solution to the problem. So this was a conversation that we had a couple of years ago, and then this got put on the back burner as we had to work on some other things. But as we started working on variations, we realized, okay, we need to revisit this, we need to solve this problem. So the style attributes table is our solution for this problem. So consider this family, Sitka, and let's suppose we're interested in a particular design variant, display bold. Now again, we're not talking here about a variable font, though the concepts apply in a variable font as well. So in the stat table, we'd identify that this family, the family that this font is part of, has 3 relevant axes of variation. It's got weight, optical size, and italic. Now I say here axes of variation, even though this isn't a variable font, but the concept is across this family, we've got these different axes in which the members of the family vary. So then in the stat table, we would add additional values that represent what this specific variant is all about. So on the weight value, on the weight axis, it's got a value of 700, and we give that a name of bold. Of course, you can also have localized forms of that. On the optical size value, it's got a particular numeric range, and we're giving that a name, display. And on the italic axis, it's non-italic, or 0 italic, and we're giving that a name of normal. And from those values, then, you can generate different family and subfamily names that are needed for different models of what a family is. So let's suppose you've got software that is working with what we hope will be the common model of a family going forward of supporting multiple axes. Then you can take those individual strings, compose them together to create the appropriate names. Now you saw normal drop out. Typically, normal as an italic value isn't used in a subfamily name. So there's a way in the data to indicate, yes, this is a name for that value, but it doesn't need to be included in a subfamily name. It can be omitted. Okay, so we've generated the names for the superfamily. Suppose I want to generate names for a GDI model. I can take those values again, compose them in a different way to get appropriate names that software should project if the software only understands the GDI family model. Or if I'm working with a weight width slope model, I compose those in an appropriate way, and then software can project the relevant families and subfamilies. And if somebody really wanted to create software that had a weight width slope and optical size family model, then they could compose those in the appropriate way. Now, we're not recommending that any software start inventing new font family models, because we'd like everybody to go to a new paradigm in which families can be superfamilies with lots of different variations. But this is a way that we have that we can bridge the gap for existing software that is constrained by these existing notions of a family. So as I mentioned, the stat table, it's required for variable fonts. It's optional in non-variable fonts, but going forward, we recommend that all fonts include it. And a note to tool vendors, you can save some work for all of your customers who are the people actually creating the fonts from having to write out those name ID 16, 17, 1, 2, 21, 22. You can be generating, if they just provide the values in the stat that are needed for the stat table, you and the tools can be providing the right name ID pairs. Behdad has mentioned the scenarios where you want to alternate the structure of glyphs in some cases for certain parts of a variation space. So consider this capital Q where there's a portion of the glyph that disappears when you get to a heavier weight. You don't want the counter to fill up. In this particular case, this is the capital Q from the Skia font, and this was implemented in Skia with variation data using what we refer to as intermediates. And you can make these structural changes by simply moving certain points so that they no longer become visible as a separate part of the structure. You can do it that way. It's kind of fiddly and awkward to work that way. And at those edges where things disappear, you can get some funky behaviors. So we think there's a different approach that could be taken, and Behdad introduced this. So the idea here is that I can create two separate glyphs, and the two separate glyphs represent the different structures, and I design them across the variable space. But I have complementary ranges that for some weights I want to use one, and for the complementary set of weights I want to use the other. And then there's that set that I don't want to be using at all. And so the combined effect looks like this structural change that occurs as you move into particular regions of the variation space. So we just define some mechanisms for OpenType layout that can accommodate this as a substitution as opposed to doing outline point transformation with intermediates. And so in OpenType, in a GSub table, you've got a feature record that identifies a particular feature and then maps that into some set of lookups or the actions that will occur. And so today there's just one set, one default set of things that happen. But what we've introduced is this notion of conditions that can condition which particular set of lookups you're going to trigger by a feature. And those conditions can be based on any of the variation axes values. So I can say, for instance, if I'm above a certain weight, or if I'm above or below a certain width, for instance, then use these other lookups instead of the default set of lookups. So if I don't meet the conditions, I go to this set of lookups. Or if I do meet the conditions, I go to this other set of lookups. You can use these for any GSub or GPOS features. And so, for instance, you could decide, I'm not going to create certain ligatures when I'm in a certain region of the variation space. But we've also defined a specific feature, the required variation alternates feature, as a GSub feature where you would just do single substitutions. This is effectively the equivalent if I wasn't implementing a variable font but had separate designs, completely independent static designs, they would have had different structures. It's achieving that kind of effect. And so if the conditions aren't met, I go into a default feature list or a default lookup list that doesn't take any actions. I just get the default list. But then if the conditions are met, then I apply a different set of lookups now that actually make some substitutions. And so in that way, you can get these different glyphs with different structures for complementary parts of the variation space. Okay, I'm going to hand it back now to Dave and Behdad to talk some about some design and tooling workflows.
Okay. I wanted to say a little bit more about how we've tried to make it dead simple for people to make variable fonts using tools and processes that you're totally familiar with. As I mentioned, Adobe's going to be releasing a new version of the AFDKO very soon, and there will be updates to most, if not all, of the commercial tools as well. But I'm going to do a quick demo here. I've got a copy of Acumen Pro, and you can see I've got, it's been built using our standard process. We've got a little folder here for each of the upright weights and widths, and a separate folder with the masters. The masters here are all in UFO format. And yeah, we have a superpolator design space file for that. And we're going to use the masters and the design space, and also actually the individual fonts that have been built, which will provide the source of the actual the deltas, as it were, for the hinting adjustments and the kerning adjustments and all the layout feature, any dependent layout features. So all you need to do here, I'm going to run a little shell script here in a terminal window where I simply there's a little now this takes less than a minute. You can watch it run right here. And there we go. And now up here in the family window, you see a new file here, the Acumen Pro VF that we've put in. And I'm going to, where's font load? Font view. Who knew?
On the right margin of the desktop.
You can look up there.
There's also an app.
There we go. I have a very special desktop. I can't actually see that part. Okay. So it's asking me to load the file, and I just point it to the new file, and I open this. This tool here, Font View, was created by Sasha Brower at Google. It's running on top of the work in progress version of FreeType that supports variation fonts. And let me bump up the point size a little bit here. And you can see smooth variation here. Yeah. Dead simple. Over to Behdad.
Oh, it actually worked. No, mirror. Okay. We couldn't possibly do this 3 laptop without any accident. Okay. So to continue on that, again, I'm demoing on Linux. This is using the FreeType version that Werner and Adobe worked on, and it's running font tools that we developed variations on. Font tools is a true community project now. I talk about it later today. And I'm using our font make pipeline, which I also talk about later today, to convert source glyphs file. So the source format has been glyphs. Convert that one to a set of TrueType compatible outlines, and typically that's how you do this. That's how you would do it. I'm not going to run it because it takes a few minutes, but I've done that before. After that, I just use a similar script. I'm just calling Python directly to convert the existing set of compatible masters into a variable file. And again, we are going through UFO and design space workflow. So FileMake has converted the glyph input to a set of UFOs and TTF and a design space file. And this tool just takes all of that and builds a variation file. Done. And let's open this in a So we call this yet another slider demo, and this is also done by Sasha. What I have here is a four-letter Arabic word. You see a ligature in the middle and two marks. The mark in the middle is attached to the second component of the ligature. Then I have, oh, what happened? Okay, let's not touch the width axis for now. Yeah, okay, it works here. See, none of this is finished. So, and you see the mark goes towards the right and then decides to go to the left. That's how it was designed in the masters. So that's GPOS interpolation. And then I also have the Acumen font that David showed. And I can run that one with the dollar text, just so you know it actually works. That animated GIF was not fake. So that's the G-sub substitution in action. So, well, that's all I wanted to demo, except for one last thing. And this is people's favorite font. I don't see Tom here, actually. So this is Buffalo Gal, one of the original GX fonts from the 90s, and it has 6 different axes, but none of them is weight or slope or anything. They just change the features of the design. So you might see the holes change. What's that one? Oh yeah, no, the serif. Yeah. This has the rounded serifs, yeah, and the shape. So what's remarkable about this demo, as opposed to what we saw earlier, is this is running in a proof of concept build of Chrome that Dominic built. Dominic and Emil of Chrome team are here if you want to catch up with them. This is right now hacked up to just work for this one, but the way we see it is width and weight and optical size should just work with variation. The regular CSS should be wired up to choose the right instance, but for arbitrary access, as Peter mentioned, all of us companies are working together on a CSS proposal to make the arbitrary access accessible from CSS the same way or similar to how you access font feature settings. And by that, I pass it back to Peter.
just before closing, I want to make, thanks, Dave, one quick comment about some of the fonts that we've demoed here. So for instance, things like Buffalo Gals, as Behdad mentioned, this was one of the old GX fonts that was created. I want people to, just to set expectations, OpenType font variations isn't exactly the same as GX. And so what you should see if you try using existing GX fonts, you'll see a lot of functionality working, but it may not be perfect because the old GX fonts don't have everything that we've added into the OpenType 1.8 spec. For instance, in the FR table, not defining the numeric values according to the scales the way we've defined them. But it wouldn't take very much work to take existing GX fonts and modify them to conform to the OpenType 1.8 spec. And so maybe we'll start seeing some more. So in closing, I just want to wrap up, mention some resources. As I mentioned earlier, the OpenType spec is now published, and so you can use the URLs up at the top. The short version goes to the current version of the OpenType spec, or specifically for version 1.8, the slightly longer spec URL you can use. John Hudson, who's been part of our working group, took on a task of coming up with a blog to announce the work that we've been doing and introduce variations in a blog post that's being published on medium.com, and that should be live right about now. And you'll probably see some other blogs coming from some of our other partners as well. And then for discussion, we've got a new category created in type drawers, and that's the venue that we want to use for having ongoing discussion and Q&A about OpenType font variations. And if you're in contexts where hashtags make sense, then we've got a couple of hashtags that we're recommending people use for this. So I want to give a call out and thanks to all of the different people that participated in making this happen. As I mentioned, we had people from our 4 companies. I forgot to mention that at our first meeting in March, we decided we wanted to include a few other people to get a little broader sense of input. So we asked a couple of people involved in types design, but with a good technical background, Eric van Vlokelen and John Hudson. And we also wanted to get some representation from tool vendors to make sure that the things that we were doing would work well with tools. So we got some other people involved in here. And it's been a great working group to work with. Everybody has been motivated to make this succeed, collaborate together, and ensure that we end up with a format that succeeds and is interoperable. And then I mentioned in August that we extended to a little broader audience a review, and I invited people to provide some quotations that we could quote, giving their reactions to the technology that we're announcing today. And so I've got a few slides here from different quotes that we collected. And we're going to go into a QA session, and I'll let these run so that you'll have a little more time to actually read them. I'm not going to read them out loud right now. So we'll go into the Q&A time. And so just so people know, we're asking that the video not record the QA session. And so it asks the video